Hello everybody, welcome back. We are going to try some of these trigonometry problems, and we're going to start off with one where we're just looking at finding the scalar values of a vector force. So we have, in this problem, we have a force of 275 pounds pulling 70 degrees off of vertical, right? And what we are trying to find here, the scalar components, are the ones that are just happening along the axes. And so that is the force in the y direction and the force in the x direction. So this is the x-axis, this is the y-axis. And what we kind of do when we split out this problem is we basically create a square that ties where these two would meet on that, a little rectangle. And this creates not one, but two right triangles. We've got a right triangle here, and we've got a right triangle here. So when we measure from the y, we've got the f of x is on the opposite side of this angle, the 70-degree angle. When we talk about this one, though, this is actually 20 degrees because it adds up to 90. 70 plus 20 is 90. This is what's called a complementary angle. Anything that is, any two angles that add up to 90 are complementary. And you can see what happens here is we get this relationship where sine and cosine are flipped for complementary angles. The sine of 70 degrees is equal to the cosine of 20 degrees. Because what we're talking about is this line right here, right? The sine of 70 degrees is that line right here. And the cosine of 20 degrees is this line right here. And those are both equal to one another. So you can actually solve this problem one of two ways. We can deal with the 70 degrees, in which case we would be using cosine to figure out the length of this line, or I'm sorry, we would be using sine to figure out the length of that side, and 70 degrees, or we can use the 20-degree angle and use that to figure out the cosine to figure out the length of that line right there. So you can choose which point of reference you want to do, but generally you want to do that according to what the problem is. But we're going to show you that it's the same thing here. It's the same thing, so we're going to use the sine, the cosine and sine of 20. So when we think about this, we've got our angle here, that is theta. So sine of 20 is going to equal the opposite over the hypotenuse. So that equals what is the f of x, or I'm sorry, the f of y. The f of y over the 275 pounds. Now, we do this an awful lot in these, is we just kind of algebraically manipulate this. If we take this and we times that by 275, these cancel out, and we do the same thing over here, 275 times sine 20. So we're going to just use 275 sine 20 when we figure out what that is. So the f of y equals 275 times sine 20. And that equals
94.06.
94.06. We're going to also do a video that shows you how to enter these into the calculator on a Windows machine. So that's f of y. If we look at f of x, it's going to be essentially the same thing. We would go through the same things there, but it would be the adjacent over the hypotenuse, ka. So we would use 275 cosine 20. That would equal
258.42.
258.42. And if we plug these numbers up over here, we're going to see that this is 94, or actually let's put it over here. Replace that. This is 94.06, and this is 258.42. There we go. That's the length of these sides here. And so that force, the force that is pulling with 275 pounds off of this direction, we could create an equivalent force by having one person pulling with 94 pounds on this direction and one person pulling with close to 260 pounds on this direction. And that would give us a vector that goes off in this direction of about that resultant would be that right there, the 275 pounds going 70 degrees off the vertical. Now, we could do this and change it, and this right here would be 275 cosine 70, and that's going to equal the same 94.06. The cosine of that 70 degrees is equal to the sine of 20 degrees. And that's true for any two angles that add up to 90 degrees. All right, that's it for the first practice.